Hi again all. In this last video, I'll be discussing question 10 and question 11. So let's look at these two questions. They are pretty similar, whereby they are going to use concepts of wave number as well as wavelength together with emission spectrum, and they're asking basically the same thing, which is to calculate the ionization energy. So let's have a look at this line spectrum and try to understand what data is given to you. All right, so Lyman series here, and the values given to you at the bottom here represents the nanometer for each transition. Okay, so previously there won't be any numbers, so you have to find the transition. Which transition is it? For example, previously what you were doing is, since this is the Lyman series, so this would be transition from N2 to N1 and so on. But now they have given you the wavelength for this transition. So this would be the wavelength for the first transition. This is the wavelength for the second transition. This is the wavelength for the third transition. And this is the wavelength for transition from N infinity to N equals to 1, since this is a Lyman series. So now using this data, okay, you have to calculate ionization energy. Previous video, you have already learned that you can calculate ionization energy using delta E formula, right? So if you were to do that, kalau awak buat jalan kerja menggunakan tu, memang awak akan dapat jawapan akhir sama, tetapi tak ada markah untuk jalan kerja. Sebab soalan kata kena guna this data. Okay, right, let's go on. So the first thing is to understand sebab ionization energy means kita kena guna data 91.2 over here, which is the transition from N1 to N infinity. All right, so what is the wavelength for the transition? That would be 91.2 times 10 to the power of -9. And since we have the wavelength, we can calculate the energy for this transition using our normal SPM formula, because we have to use the wavelength information, yeah? 6, okay. And then we calculate the energy for 1 electron. Okay, so this is for 1 electron, the ionization energy for 1 electron, and for 1 mole of electron, we times it with Avogadro number, and you get the final answer 1312 kilojoule per mole. Simple and straightforward like this. Okay, now let's look at the next question. This is a bit tricky. Okay, because they have given you something called wave number, and I've not introduced you this. Okay, so what is this wave number? So wave number basically refers to this 1 over lambda is known as wave number. So lambda means wavelength, and 1 over lambda means wave number. So they have given the wave number for each transition. Okay, so our first task is we have to convert this wave number to wavelength. All right, so let's first write in the values. Okay, so I would write in the values. The E would be 9.35 and A would be 10.95. Okay, just write the extremes, because the question is asking you to calculate ionization energy. Which one would you pick? Obviously A, because the thick line here indicates that this is a transition from N1 to infinity, and that would be the wave number. So now what would be the first step for this calculation is that we convert, okay, we convert our wave number to wavelength. So how are we going to do that? So wavelength would be simply 1 over wave number. Okay, now let's put in the values, which would be 1 over 10.95 times 10.95 micro per meter. Okay, so now how are we going to convert it into wavelength? You must understand that this whole thing is together. All right, so 1 over micro per meter simply means it is micrometer per 10.95. I hope you can see this because micro per meter here is together. So since this is 1 over per, therefore you can bring the micrometer on top, which will give you 1 times 10 to the power of 6 meter divided by 10.95. And your answer should be 9.132 times 10 to the power of -8 meter. Alright, so once you have the wavelength, what to do next? Because question is asking you to calculate ionization energy. Now we go back to our SPM formula, delta E equals to Hc over lambda. Substitute in the corresponding values, which would be 6.6256 times 10 to the power of -34 multiplied by the speed of light and divided by the wavelength that you have just found. So your final answer should be about 2.178 times 10 to the power of -18 joule. And again, please make sure you notice that it is kilojoule per mole. Therefore, you have to find for 1 mole of electron. Okay, so therefore, ionization energy G for 1 mole of electron would be 2.178 times 10 to the power of -18 multiplied by Avogadro number, and the approximate answer should be 1312 kilojoule per mole. Okay, I hope that helps for those of you who have done the tutorial. If you have further questions, do ask me when you meet me next week. Thank you.